this is probably the unit where you're gonna realize having your own calculator, a good one, is gonna pay off. This is the unit where you're gonna be frustrated if you don't have a good calculator. So sine law is the first law we're gonna cover. Then there's cosine law. That's it. 2 choices. Before you had sine, cosine, and tangent. Not with this unit. Like sine law, cosine law. That's it. So here we go. Since we're working primarily with oblique triangles, most of our triangles are going to be oblique. What does that mean? It's not a right triangle. So you cannot use Pythagorean theorem. You cannot use SOHCAHTOA, right? We will not be using primary trig ratios. So SOHCAHTOA, do not use them. There are instances where that is an option, but I would say don't do it because sine law works for all types of triangles, okay? I will put this down. Sine law works with right triangles and oblique triangles. That's the beauty of sine law. It works with right triangles and it works with oblique triangles. And I'm going to review a little bit because I know COVID has really damaged a lot of what happened in 10 and 11, you leading up to this point, right? Like it just wasn't the same. Some teachers didn't know how to work technology. Some teachers just, right, they tried their best under the circumstances. And so I'm going to try to review just a little bit before I move on to the actual unit. Okay, so if you know this, bear with me, right, just for a little bit, and then I'll dive in. That's just how I am. I'm like, it doesn't hurt you if you know this stuff. It's a good review. And if you don't know this stuff, this is your chance to maybe jump on the train and follow us on our journey, right? Next page. So just flip to the back of the front page. These are things you should be already have knowledge of. Okay. So the sum of interior angles is always 180 degrees. And that is a triangle, by the way. So draw a triangle that is clearly offset like this. So draw a triangle that, right, is offset, right, like this. Angles, if you see degrees, right, it measures the opening, right, between two sides. Sorry, it's a little small, so I'll zoom in just to this part here. Right? So this triangle, let's say that was a 50 there, and on this opening here, it's 35 degrees. Let's say you have this angle up here, which is unknown to you, question mark. If you have two angles, find the third one just like this. I will just say angle X is going to be 180 minus 50 minus 35. Let's do some mental math here. 180 minus 50, 130. Take away a 35, that's 95, right? I want you to show your work. When you're using this property, please show that work just like that. Take away the two angles from 180 and you're left with the third. I can't tell you how often students forget this. So they're stuck on a question because they're not finding that third angle, right? Find the third angle right away and it often solves your problem. Okay, next, the three types of triangles. They're famous. Isosceles triangle is a triangle like this, it looks symmetric, and two sides, it doesn't matter which two, but there are two sides that measure the same. So these are the markings that indicate that. And if you were to travel across those sides and mark that angle, and you take the other side and you mark this angle, those angles would also be the same. Guaranteed. In real life, you make a triangle, two sides are the same, the angles across from them will be exactly the same. Okay, so this is the definition. Two congruent, watch what this, an equal sign with a squiggly third line, that means that they're the same. So two congruent sides, two congruent angles. Congruent is just a fancy word for saying equal. And the reason I'm using it because you will see that in worksheets. Congruent is the same as equal, or they are the same. And let's just put an arrow to that symbol so you know you're not scared of it. It's just that's what it means. Equilateral. Equilateral. All sides are the same. That's what that word stems from. So all three sides are the same. And so if all three sides are the same, guaranteed that all three angles will be the same also. Same property as the first one, right? So all angles are congruent. All sides are congruent. Let's see. What does each angle measure in an equilateral triangle? How many degrees? 60? All angles equal 60 degrees. Okay. Does it matter if it's a big triangle or a small triangle? If all sides are the same, it will still be 60, guys. It doesn't matter if it's a tiny or a big triangle, it's always 60. Okay. All right. Right triangle, I think you should all recognize that it's the box that gives it away. Okay. If you have a 90 degree, that is 90, by the way, folks. It actually represents a number. It's 90 degrees. Some students forget that. So you have a, right, that gives away. So sometimes if you just subtract the two you know, and the third one is a 90, then obviously it's a right triangle. So those are your three types of triangles. Supplementary angles, what are those? Anybody willing to say, tell me, if two angles are supplementary, what do we know about those two angles? They add up to something. Nobody? Not 90. 180. And see, the reason I'm asking is because students, even I forget, right? So think of this way. It's right to complement someone. So you're like, what do you mean? Complementary angles are 90, supplementary 180. So it's right to complement, so you know complementary is 90, supplementary is 180. I don't know if that helps. Anyways, so this is really what you're looking at. If there is indeed a straight line, just draw a straight line like that, right next to it, and you pick any point. I happen to pick right smack down in the middle. If you were to measure from this, because right now I split it into two lines, correct? If I measured the angle from that line to the other line, it would be 180 degrees. So a straight line, half a circle, right? 360 is a full circle, half a circle is 180. So if you have two or more angles that add up to 180, you have supplementary angles. So let's do this here. Draw a line like this, slight slant, but it's a straight line nonetheless. And pick a point anywhere on there. I can pick right here. And let's make an angle come in like that. Split that. So it's like 3 lines coming out of that one point. And I will highlight the straight line. There's only one straight line there, which is this one. If this had been 50 degrees here, if this opening here is 50, what would this have to be? And you're like, well, it's a straight line, so 180 minus 50, this has to be 130, right? Because both of them I know are along that straight line, so they have to add up to 180. Here's another one. Let's make it this way. Right? Pick a point anywhere. You can pick it right here. Make a nice big dot. Let's make a ray come into it like this. Arrowhead there. And another one going straight like this. You're like, whoa. Right? What's going on here? There's only one straight line, correct? This one right here. So if I were to tell you that this angle is 70, and I told you that this angle is 80, that looks more like a 100. That looks more like a 95. Let's put it 95. It's bigger than a 90 for sure. So if this is 95 and that's 70, what would this have to be here? Well, 95 and 70 is 165, right? How much more do I need to get to 180? 15, right? So all three of those add up to 180. So these three angles would be referred to as supplementary. And you're like, well, what does this have to do with triangles, Mr. Dirksen? Watch this. Right? You make a triangle. Just make a triangle like this. And sometimes they get sneaky on you. They do one of these. They extend one of the sides like this. In this case, they extend the base. And they'll tell you that this angle out here is 120 degrees. And you're like, it's not inside the triangle. It doesn't really help me. Yes, it does. You should recognize that there's a straight line there. That's just a mental math. If this is 120, what will the inside here be? That's right. Boom. Now you have an angle inside the triangle, just like that. You actually are using the property of supplementary angles. Okay? So never underestimate the power of a straight line, right? Like 180, right? It goes a long way to help you out. I'm going to scroll up a little bit. Notation. Okay, I don't want you to struggle with notation, but you will. Unfortunately, you will come across this one right here. This one is not a pleasant one to deal with. So do this for me here. Just a straight line like that. Arrowheads on both sides. And just cut it anywhere you want, like this is how I am doing it. And put dots on the end of these lines like that. And watch what I'm going to do here. I'm going to go A, B, C, D. If you have a highlighter, you highlight. If you just have a pencil, you will mark the one you want. So let's say this question is talking about this angle right here. I want to talk about that angle right there. Can I just say angle D? If I just say angle D, like would that narrow down which one of these two? Because there are two angles, right? There's one here and there's one here. But I want to refer to this one. Yeah. BDC, that's correct. Yeah. So we would say angle BDC. So you cannot start with the point where you're interested in. You have to travel out. So you have to say angle BDC. That's right. Which can also be written as, so let's say you want to start here. Look up on the screen, okay? CDB, that's the same angle. If you start here, angle CDB. And you're like, oh my goodness, right? But watch this. Both of these have D in the middle. That's the important part. So it doesn't matter if you start CDB or BDC, right? It doesn't matter as long as D is in the middle. But this is how I'm going to make your lives easier. Once you know which one they want, do this. You'll say, well, I don't want to deal with that three-letter notation. I really don't like it. I'm going to make that angle X. So then you go in here and you call that angle X, right? And so from now on, you will call it angle X. Like you stop using the three-letter notation. But sometimes I will ask you, find angle CDB. So I want you to know which one I'm talking about. Okay. Let's do one more. I'm going to use orange. Orange, you glad it's the last period of the day? Anyways. Angle, if you want to talk about that one, you can start here, ADB. Or you can start, this one is exactly the same as starting from the top and just saying BDA. And because some of you don't have a highlighter, I do this part. I'm just going to call that Y. So angle Y is right there. But notice that D is still in the middle. Okay, I'm just not going to highlight that. Just going to leave it. But there it is. Okay, so three-letter notation in a nutshell. This is a crash course. I know some of you are like, I need more. Maybe I'll be able to do that down the road, but not now. I want to get to sine law. Angle of elevation and depression. This one is very important for you to distinguish between. So I'm not an artist, so here we go. So if you're not an artist, you're in the right place. It's going to be easy to graph this, okay? So what I want you to always think of is a horizontal line. So go right where the eyes are and just go straight out. This is your horizontal. The horizon, right? The sun sets in the horizon. And then imagine that you're looking something that's above you. It could be a plane, a bird, a kite, you name it. So let's draw a bird here. Your line of sight is there. And so the angle of elevation is created here. Angle of elevation. I will ask you from time to time, where is the angle of elevation in this diagram? You have to be able to tell me that. So let's imagine now the ground is right here. It could be water, it could be the ground, you name it. Let's say, for instance, you're looking at a bug crawling, right, on the floor. And so your line of sight is now focused on that, whatever you're looking at. It could be a boat. It could be that you're on top of a cliff looking down and spotting an animal. or a person or an object, right? This angle right here is called the angle of depression. That angle formed is the angle of depression. I'm going to say this. There has to be a horizontal line in the mix. If you don't get the horizontal line in there, you're going to get it wrong, okay? I will say that one more time. The horizontal line has to be in your diagram or else you'll get it wrong, okay? Here's what I'm talking about. The most common mistake. Ready for this? You're not going to write it down. You're just going to look on the screen. So there's a scenario where you're on top of a cliff up here, and there's water, and you're spotting a boat down here, right? So the question is like, hey, you spot that. Okay, I get it. That's going to be my one line here, and the angle of depression is 50 degrees. And the student's like, yeah, I get it. This is going to be my triangle. I'm going to put the 50 in there because it's the angle of depression, right? Is there a horizontal line right there between the 50 and the site? No, this is wrong. What you need to do is imagine a horizontal line going out like that, and that's where the 50 would go, between the horizontal and the line of sight, okay? And actually your triangle is going to end up being like that, okay? So you have to be careful with that. Common mistake. Maybe this is the last thing that I'm going to review from the previous grades. I think you all, like, obviously you know your compass directions. North, south. This is always the kicker. Which one goes where? You have to read we, not you, right? If you write it like this, it's you, right? From left to right. Can't have that. So it's west. We, yeah, soggy wieners, like all that. Yeah. Never eat soggy wieners. Yeah, whatever helps. You go with it. Yeah, don't let me. A tree is due east of you. What if a question says a tree is exactly due east of you? That means that this is you, and the tree would be right next to you, right here, tree, right? Because the tree is to the east of you. So that's what the question is saying, right? You draw a dot for you, and then east is your tree, okay? Sometimes it's north of you, due south of you. It doesn't matter. Just make sure you know that. This is the most common mistake, so get that right. Next, let's start with the actual. At the very top of page 260, you're going to say sine law. And we're going to start with sides. We're just going to first solve sides, and then we're going to do angles after. Okay? I'm going to jump right in. Okay? This is basically just telling you what I just told you, that oblique triangles, right? Then you can't use SOHCAHTOA. This is the solution to that problem. Highlight this part. The sine law can be used to solve side lengths and unknown angle for oblique triangles in certain situations. This is what the law states. This is the sine law in a nutshell. Okay. I will say this though, because I know, note, we set up a proportion with one equal sign. you will not have the two equal signs as stated by the theorem. Okay. And I will say this. Sine law has to do with pairs. So watch this. Sine of A, right? Sine of angle A is over side A. So notice this. Capital letter for A and lowercase letter for the side that's across from it. So actually you have an arrow going from angle A to side A, and so you know that that's the side length. If you have different color highlighters, today's your day where you get to use them. And B, right? Here's angle B, and across from it is side B. That's the convention. That's how we label triangles automatically. So you start from your angle and you go across like that. And the last one, I'm going to use my green one. C goes with C, C goes with C. Okay, so you have your three pairs. There will be three pairs essentially in any given triangle. Notice this. Capitals, capital letters represent angles, lowercase represents sides. Okay? That I would not think that it's new to you. I think that you should know this already. And now we're going to dive into the math part, which I think you're going to enjoy. You're going to enjoy the math part. Let's do one more. One more thing here. We have the space. So let's say you have a triangle like that. Okay? And you're given X, Y, Z. Right? You're just like, that's a triangle. That's triangle X, Y, Z. What I would suggest you do is label the side lengths across from them using lowercase letters. Okay, so I go, this is angle Y, I put lowercase, capital Z, right, lowercase, or Z, whatever you learned, grew up with, right? And so that's how we label triangles. Called triangle XYZ. So that's what we would call that triangle. It doesn't really matter the order in which you come up with the letters as long as you have them in a row, right? So you start at Z, for example, and triangle ZXY, same thing. So labeling is important to get it right. Okay, so I'm going to first start with solving sides, then I'm going to solve angles. So you will be doing some work in a little bit, okay? Flip over. That page is empty, blank for a reason. There's only one triangle right there. And I always like to pretend like we don't know we're going to use the sign. Okay, so basically, can we scratch this? all the way to, right? So just say calculate the length of side A. So let's imagine this question is just saying, hey, find side A. And you're looking at A, B, C, right? Side A is already labeled, which we knew was here. So they're basically asking us to solve for that side. We cannot use SOHCAHTOA, guys. There's no 90-degree angle anywhere here. But do you see a pair? You should see a pair. That's what I call a pair. You know the angle and you know the side length across from it. Guaranteed, right? You got to use sine law, right? Because you have a pair. Let's put a pair right up here. Pair exclamation mark. If you have a pair, we're going to use cosine law later. But if there's a pair, you have to start with sine law, guaranteed. If you remember that, your life is going to be a lot easier. So here we go. This is how I do this. You go sine of 52 degrees over the side length, 16.8 centimeters. And that will equal to another pair, but we only know one of them. We know sine of 72. Sine of A is, right, sine of 72. And lowercase a goes here. I need to emphasize this. You're picking this angle because you're trying to find the side across from it. And so 72 never shows up like that, guys. It's always glued to sine, right? You can't just put in 72 in there and hope for the best, right? A is there. So you should recognize that this is a proportion. You cross multiply like this and you divide, just like we did with fuel economy. Right? So you cross multiply and then you divide. So let's go ahead and do this. I don't want you to have an equal sign next to it. Don't do that. You're going to lose marks for it. So you just say A, which is my variable, is 16.8. I tend to start with this, but the fact is that these two multiply. And I like to use brackets. Divided by sine of 52. You show your step, and then you state your answer. And A is a side length, so I'm expecting centimeters, right? This is where you grab your calculator, whatever calculator you have, and you give this a go. So I'm going to go 16.8 times sine of 72. I hit equals at this point. And then I go divided by sine of 52. Hit equals again. And I get 20.28 if you round that correctly. 20.28 centimeters. You've now solved side A. I'm not done yet. I'm going to add a question to this. Right under this, I will do an extension here. Calculate the length, write this down, of side C. Calculate the length of side C. I would say start with that pair again that you knew from the very beginning. And you want side C, right? Do we know what the angle is across from C? Not yet, right? So let's, as you're writing this down, go up with me. It's important that you see the graph. Right now, I don't know what either one of them is. I need to know this angle before I can figure out the side. You have two angles. Find the third. Okay, so this is what I'm going to do here. Find angle C first. Okay. Angle, you know what? Sorry, I'm gonna make you erase it. I don't want that there. Sorry about that. I'm gonna do it on the side. Find angle C first. Angle C is 180. It's always 180 for a triangle. I subtract the two angles that I do know. Angle C ends up being 56 degrees. Don't box it in. I can underline because it's important. And so this is angle C, which I need to find side C. So I'm going to go sine of 56 degrees. And I put an arrow, right, in there, like that. And then you cross multiply and divide just like before. So 16.8 sine of 56 divided by sine of 52. So C that's 17.67. And right now, what you can say here is we solved the triangle. What does solving a triangle mean? Anybody know? You should have heard it before. All the sides, all the angles. So if you think about it, you always need three things to get you started. You need three things, right? If you think about it, we knew two angles on one side, right? And we found three other things. We found two sides and that third angle. So you have solved the triangle indeed, okay? There's one more thing I want to add before you start working because I need you to check. So this is kind of a nice break from SOHCAHTOA because if you just know I need my pair and on the other side I just got to make sure I pick the right angle, I'm fine. Let's add that to the bottom corner here. Add it right here. So what I need you to know is that the longest side will always be across the largest angle. And the smallest side, or shortest side will be across the smallest angle. If you remember this, this will come in handy, guys. This will. So I'm not just giving that to you. Say, hey, fun fact, like it's coming back. Look at which one is the longest side we have. If you look at all the side lengths, it is 20.28, right? Is that across the largest angle? Let's just check real quick. I'm looking at my diagram, and 72 degrees is the largest angle. You have the longest side across from it, okay? And so you know you're doing it right. Because sometimes folks somehow grab the wrong number and they just go to town. If it doesn't add up, you need to make sure you do that. Okay, so go to the next page. I'll make some changes to it. So go to the next page right here. I want you to solve. It says calculate the length of the indicated side, and I'm going to say nope. Calculate the length of all sides. You can start with the one that they indicate, but I want you to find all sides. And I will give you a hint. Do one of the sides on the left side and the other side on the right side. That will give you enough space to do all the work right here, okay? So I'll give you some time to do that, and then we'll do angles. So you probably will only have enough time to finish the first two, and then I'm moving on to the next one, okay? So go for it. Get your feet wet. I will ask you to do this at the top here. Sine law, and we'll put down angles. Okay, so if you're wanting to solve for a side, I just gave you an example. If you're wanting to solve for angles, this is your example. It's a little different at the end. The beginning is exactly the same. Okay, so you just got to remember one thing that I'm going to show you in a bit. So you recognize that there's a pair. Okay, I'm going to use that to get me started. This is on 263, all right? Which angle makes more sense to solve right off the bat? Angle A, right? Because, right, if I want that angle, I do have the side across from it, so that's the go-to, all right? So I know it's last period, but you can do this. You go sine of 81 degrees over, right, sine of the angle over the side, 123.2 meters. And on the other side, watch this, you want angle A, right? You can't just write down A. You have to go sine of A. So sine goes with the angle every single time. If you don't know what the angle is, put a letter in it. Okay? And then you put the side length. So just by looking at this, are we expecting angle A to be greater or smaller than 81? This is 123, this is 91, right? So this angle will be smaller because it's a shorter side across from it, all right? So here we go. You treat this as your variable, you cross multiply like that, and you divide going down. So you cross multiply there, you divide going down. So 10, 10, right? So let's do this. You need to keep sine right next to A. You cannot drop it yet. That's the tricky part. So you go 91.6 times sine of 81 degrees divided by 123.2. You do your setup. And this is where you can add a second equal sign like this. You cannot do it up here because it's proportions. Here you're operating, you're doing an operation. So you take that and type it in. I would invite you to do the same. Times sine of 81. If your calculator has a bracket that opens, make sure you close it. I'm going to go equals, then divide by 123.2. And I'm going to use 5 decimals. All if I could. So 7, 3, 4, 3, 5, and that keeps going. Right? So you just told me that this whole thing actually amounts to this. I will say this. If your number doesn't start with a 0, you made a mistake. It's going to give you an error. You're not going to be able to solve it. So this has to start with a 0, okay? Must be 0 to start. Next line is this. Watch carefully. Angle A, so watch, the sign dropped, right? it shows up on the other side like this with the little -1 on top. It's called inverse, the inverse of sine. Anybody remember inverse? Yeah? All right. Some of you might not. And you plug that decimal in there like that. I prefer to use all decimals. My calculator has that. Some of you might not. So this is your way around it. Angle A now, this is our final. So watch this. I still have that on my screen. I'm going to go shift or second or whatever. You have a button that allows you to select sine inverse. So shift, and then I press sine. It calls that. And when I press equal, it will automatically take the inverse of that answer I had on my screen. So I'm using all decimals here. And so I get 47.25 degrees. 47 point, you're finding an angle, remember? It has to be in degrees. $47.25. And we're not done yet. One last line here. How many angles do we know now? 2, right? This one and this one we just found. So let's find the third angle. Angle C is 180 minus 81 minus 47.25. And you're done. So it's 51.75. That's all it wanted. You could now go ahead and find side C because that's still unknown to us. But we're not going to do that. I'd say this. If you're not done yet, go back to the previous page. And I'm going to leave this one as is. I'm not going to ask you to do one of these, but unless you want to. But you go back and keep working on the one I just gave you. I just wanted to make sure I got this into the lesson.